we have this calculator problem with this velocity vector asking us for speed, acceleration stuff, total distance traveled there. So we get to use the graphing calculator to help you out with a bunch of this stuff there. So the first thing I did was recognize, okay, this is the velocity vector. There's the position as X and Y. Velocity is going to be X prime and Y prime. So that's what they're giving us right there. So the first thing I did is I graphed both of those functions into my graphing calculator. So I got both of those entered in. And if one of them has trig in there, I usually will hit zoom 7 when I graph it. So I hit zoom 7 and the graph just kind of looks something like that. Now, when we do the speed of the particle, there's two parts to part A. You got to remember to do both of them. We got to do the speed and also the acceleration vector. So the speed formula, remember from your blue packet, in case you need some help with that, that speed formula is just the square root of X prime squared plus Y prime squared. And so what I did, I set it up like this. The speed at 1.2 is the square root of X prime of 1.2 squared plus Y prime of 1.2 squared. And you can get those numbers from the calculator. So if I hit the trace button, that's that first one. That's the X prime. So if I just type in 1.2, it gives me this 0.844139116 number, right? That's X prime of 1.2. And if I use the down arrow, I already got the trace button highlighted. So if I hit 1.2 there I'm getting this 0.950847775 number. So I'm supposed to square both of those, take the square root of that. And so that's what I already did right here. So I probably didn't have to use as many digits, but I was a little bit concerned about rounding to the very end. So I used a bunch of the digits there. You kind of see how I typed all that in. And then when I hit enter on that, I was able to get that 1.271 number. Now, to get the acceleration vector that gave us velocity, we know it goes position, velocity, acceleration. So to go from the velocity to the acceleration, we need to take the derivative. Now, instead of taking derivatives of both of those things there ourselves and plugging in the numbers and messing around with the proctor and stuff like that, remember, this is a calculator problem. We can use the Math 8 feature. All right, so I'm going to use the Math 8 with both of those functions. It will take the derivative for us at that 1.2 number right there. So I need the X double prime and the Y prime. So let's review that real quick. So I'm going to hit Math 8. And then since I already have in there the X prime is my Y1, the Y prime is my Y2. So I can just hit in my variable button. I can use my alpha trace key. There's my X prime of T right there. So if I use the Math 8 function at 1.2, it will take that derivative for me. And that's giving me the acceleration is that 6.247 number. And I can do the similar thing. I'm going to do Math 8. And this time I'm going to do alpha trace. I'm going to highlight my Y2 because I already have my Y prime in there. So that'll take the derivative of the velocity for the Y's, and it'll give me the second derivative of the Y's. So that'll give me the acceleration. And that gives me that 0.405 number. So make sure you don't go too quick and just do one part of that. They're asking us for the speed and the acceleration vector, and make sure we're practicing that and getting quick with that stuff on the graphing calculator. For part D, part B, it says to find the total distance traveled. So the total distance traveled is just the integral of that speed formula right there. So that distance traveled is the integral of the square root of the X prime squared plus the Y prime squared. So it's just the integral of your speed stuff right there, which we've seen before. And so since I have both of those functions in the calculator, I can just do the Math 9, and I can go between 0 and 1.2 because that's what the interval gave us there for part B. And I'm going to have my square root function. And then I have those as my Y1 and my Y2. So now I can just do alpha trace. There's my Y1. I'm supposed to square it plus alpha trace. There's my Y2. I'm supposed to square it. And then you need to always show the setup. Please always show the setups for your stuff you're plugging in, like the speed, the acceleration vector, the integral for your total distance traveled. Show that setup. And then they're expecting us to go to the graphing calculator to get the correct answer right there. So we always round to 3 numbers. So I got 1.010 there, the way that worked out for us. But make sure you show the setup for your integral and then go to your answer. They said if you just have the answer down, not that integral setup, that's your support, you're not going to get credit for that. So make sure that you're showing all that stuff and then going to the calculator. That just helps you out too, because if you have this and mess it up, then you're going to get points for that. All right, so the last part of that, here's all of part C, all kind of together here. And then that's the toughest part of this particular problem there. So when it tells me the final coordinates, so right away I said, okay, it's not just an X value. So I made a note for myself, I got to find an X and a Y value for the particle is farthest to the left. Now, when I saw that farthest to the left means we're talking about X's. We're not talking about Y's up and down. We're talking about X's left and right. So farthest to the left means I wanted to minimize like that X prime, all right? I wanted to minimize the X's. I want to minimize the X's. And so that involved taking the derivative and setting that equal to 0, and then seeing if that changed from negative to positive for that to be a min there. So again, farthest to the left, you want to minimize the X's, which involves taking that X prime and setting that equal to 0. So that's what I did. So if you just write down, hey, X prime is equal to 0, they're going to give you something for that, just for that recognition there. So X prime is equal to 0. The e to the X graph never crosses the X axis. That's never equal to 0. But when I set this part equal to 0, we get T is equal to 1. All right. So you set that equal to 0, you get your T is equal to 1. And then if you look at just your X prime graph, that X prime one is this guy right here. So see how it starts off at 0 right here, and then it goes up, it crosses. So at T equals 1, that's crossing right there at 0. All right. And then notice in between 0 and 1, that X prime is negative. So the velocity is negative. So it's going to the left. All right. And then at T equals 1, when T is bigger than 1, now the velocity goes above the X axis. So the velocity is going to be positive, which means the particle is going to be going to the right there. So notice that T equals 1, though, this is my derivative function there. I could even take off, I'll leave that in there, but I'm just looking at this guy here for the X prime. So to the left of that, the velocity is negative. To the right of that, the velocity goes to be positive. So if that velocity, that X prime graph changes from negative to positive, that's what's making that a minimum point right there. And again, at T equals 0, they told us we're at this X equals -2. And then since my derivative is negative in between 0 and 1, that means, hey, my velocity is negative, I'm going farther to the left. And then at 1, my velocity is positive, I'm going to go farther to the right. So at that T equals 1, that will be the point where we're going to be farthest to the left right there. Okay, so because the derivative changed from negative to positive, and because what we got talking about right there. Now, at T equals 1 is fine. So if you say, hey, my derivative is equal to 0 and get that T is equal to 1, you know, we're good here. We got some partial credit on this problem. But again, at the beginning, we said we need the coordinates of this thing. So I need an X and a Y. So when T is equal to 1, I need the X and the Y. And so what we need to do here, if I integrate the X prime, that gives me X. If I integrate the Y prime, so remember when you integrate the velocity in between 0 and 1, these two expressions here just tell you how far you went in between the 0 and the 1. But if you want the position, you got to always take into account the initial position. So that's why up here it tells us at time T equals 0, we have the initial X and we have the initial Y. So at T equals 1 is the point where it's farthest to the left. So I need to find X of 1, which that involves taking X of 0. The initial position they told us was the -2. And if that's where we're at T equals 0, you pick it up where you left off and you integrate from 0 to where you want to go. So I'm going to do the math 9 with this function, and then that's going to give us this value there. And I'll show that in a second. And then the Y of 1 is going to be Y of 0, which they told us was equal to 5. That's where we're at T equals 0. And then you pick it up where you left off and you integrate between 0 and to where you want to go of the 1. And so when you integrate that Y prime, that tells you how far those Y's are changing, but then take into account that initial position right there. Okay, so to do that on the calculator again, we can just go -2 plus, and I got the math 9. I'm going to go in between 0 and 1, and that X prime is my Y1. So I hit alpha trace. There's my Y1 right there. And notice we're getting that -2.604 number for the X value. And then the same thing, I can go 5 plus math 9, 0 and 1, and I can do alpha trace and then type in my Y prime. That's my Y2. And then that gives us the 5.410 number. So that's my X and the Y. So that's why I got the particle as farthest to the left at that particular point right there. So a challenging problem, have to do a couple things there, not just stopping right there. Have to make sure we're justifying that properly, have to make sure we're finding the X's and the Y's, have to make sure we're taking into account the initial position. So it's a good challenging problem for us to do in learning from this one. If you had some issues with that, now you're studying that and you're learning that, and you're going to be able to better tackle that in the future right there. Now, the last part of it says, explain why there is no point at which the particle is farthest to the right. So my thing there is, if you look at that x prime graph, to the right of t equals 1, that velocity, this is your velocity, that x prime graph is positive, which means that just keeps on going and going and going and going and going to the right. There's not a spot where, you know, it's came back down and it went like negative or something like that, where it switched direction on us there. It didn't switch direction. So my mind there, I just put, hey, there's no point where the particle is farthest to the right, since the graph of that x prime of t is always positive. When you're beyond that t equals 1 there, and it stays positive, means it just keeps on going and going and going to the right. So it doesn't like turn and go back in the other direction and go farthest, you know, have like a rightmost point and then it goes back in the other direction right there. It just kind of keeps on going right there. All right, so do the best you can with that. And then if there's anything that's still unclear to you that you want to talk about, just please let me know, and we'll go through some individual questions with that stuff too. All right, orca whales, orca, it's a neat word.